Okay, hi guys. So today will be a quick video. We'll be solving Leetcode problem, maximum number of points from grid queries. So we are given a matrix and an array of queries. So for each query, we need to find an answer by doing the following process. If queries I is strictly greater than the value of the, so basically for each query, then we start at the top left, right? And if queries I is strictly greater than the value of the current cell that we are in, then we get 1 point, and we can move to any adjacent cell in 4 directions: up, down, left, right, basically horizontally and vertically. Otherwise we do not get any points. So basically, if we go to a cell where we have already visited, then we don't get an addition point for that. So let's take a look at this example. So we have these queries, right? So 5, we start here, get 1 point, we go here, that another 2 points, go here, right? That's another 2 points. We cannot go here. We cannot go here because 5 and 7 are all of them are larger or equal to 5. So 5 is the answer for queries, the first queries. So for 6, we can visit 5, 5, and 1 now. We cannot visit this cell, so the answer for this is actually 8. So for 2, we can only visit this cell, right? Okay, so basically we are counting cells. Just forget about point. We are counting cells that we can visit for each queries, right? And then now, what is the brute force way? The brute force way is that for each of the queries, we are going to do a breadth first search from the top left cell all over again, right? All over again. We can use breadth first search or unified, whatever you like, right? Okay, so that's one idea. How about if you take a close look at the answer, you can find out that if the query goes up, then the output goes up, right? So for 2 we have 1, for 5 we have 5, and for 6 we have 8. And it's understandable. Why? Because if the queries goes up, then we have more space to go to, right? More cell to go to. We are not limited to a lower value. We have increased our bound. Therefore, we can go to potentially additional cell. That's why we have higher value. So what is a wiser way to do this problem is that we are going to sort the queries, right? We are going to sort the queries, and then for each of these queries, right, we'll go from lower to higher, right? And then when we do a breadth first search for a lower queries, there's a high chance that we are going to visit a cell that we not yet have the ability to visit that cell yet, right? So for example, we are going to sort these queries, and then we have 2 as the first queries, right? And then we the only cell that we can visit is these cells, but our breadth first search is going to reach this guy and this guy too. And then what are we going to do next? We are going to store all of these cells in a heap queue, right? A min heap. And then once we get to these queries, we are going to basically, instead of doing a breadth-first search from this guy all over again, we are going to do breadth-first search from this guy and this guy, right? Is that going to be more efficient? Clearly, right? So basically, for each query, we are going as far as we can, and then we are going to basically then for cell that we cannot visit yet, we are going to push it into a min heap, and then for the next query, we are going to pop this guy out of the min heap if and only if the value of these cells are smaller than the next query. And then we are going to continually doing breadth-first search from this cell only, instead of going to do breadth-first search from the top left cell. And then at the end of each breadth-first search, we are going to append the length of the visited set into our result array, right? And that's basically it. We are going to use three techniques. We are going to sort the queries from small to large, do breadth-first search, and store cell where we cannot visit yet into a min heap. For once we get to another query, pop from the min heap cell that we can visit now and do breadth-first search from there, instead of doing breadth-first search from the top left cell, right? Okay, so now we are going to implement it. We are going to need a scene set, a queue. We are going to sort our queries. Basically, we need to remember the index of each queries, right? Because we need to return the result in the correct order, the original order of the queries. Okay. Basically, value index for index value in numeric queries, and then we're going to do query.sort, right? And then the result, you can do whatever you like. I'm going to just refill it with 0. Okay, so now we are going to do a breadth-first search for each query. So for in query, let's call query index in queries. Okay, so if you take a look at this example, you can see that there's going to be cases where we cannot get to any points because the first point is blocked. Alright, you can see here the query is 3, but 5 is larger than 3, so basically we cannot traverse to any cell, right? So we are going to do this. We're not going to prefill, we're not going to add a 0, 0 into our queue and our scene set just yet, right? We are going to basically do that at the beginning of each query, right? Because we're going from low to high. If a low query produce a zero answer, there might still be a chance that the higher query can visit the first cell, right? We are going to do it at the beginning of each query. So if query 0 0 if 0 0 not in scene and query 0 0 is smaller than query, we're going to add into our queue and add it into our scene set, right? Okay, so what is the next step? Well, the next step is that we are going to pop from the min heap a cell that we can visit now and do BFS from there, right? Okay, so while store and store 0 0 is actually smaller than our current query, then value row call will equal to, we're going to pop from that, right? Then we're going to append it to our queue and our scene set. No, 0 0 the row and call, right? Okay, so what is the final step? The final step is that we're going to do breadth search from our queue, right? By queue queue this, right? We see in right, the new row and new column could be R plus DR, C plus DC. If 0 smaller equal to new row and then smaller than R, basically they are inbound, and NR and C not in visited. There are basically two chances. There are two possibilities that can happen here. One is that if if the value at this new row and new column is actually smaller than current query, right, then we're going to just append into our queue, right? Else then basically, right, we are going to push it into our min heap to use it as the starting point for next query breadth search, right? Push into our store. What are we going to push into it is that we're going to push the value and then the row and the column, right? Okay, so at the end of each query, going to is equal to length of scene and just return the result. That's basically it. 580. Here we have 2202222. Okay, so let's see what are we doing wrong here. Query index and query 0 scene. like store 00 small and query. What did I do wrong? Here first query produce 0. Sorry, here's actually grid, right? Okay, so that's it. So submit it. Okay, as you can see, it's pretty efficient. Okay, so I will not go into detail about the time complexity. Okay, so that's it. I think this is a pretty interesting hard problem. Basically, we can use 3 techniques here, right? Sorting, breadth-first search, and then a min-heap. It's not like incredibly hard. You can basically still think about the solution and then grind it out if you spend enough time. Basically, for this problem, I spent around 30 minutes, right? Okay, that's it for today. Thank you guys for watching, and see you guys in next video.